Hello everyone, welcome back to another episode of Math Unlocked with your host, Mrs. Rhodes-Grierson. Now, today we're going to go into our section 2 of January 2026 past paper. I hope that you are ready. I hope that you would have enjoyed watching section 1. You would have learned a lot after watching section 1. And now that you're back, let's get into it. Now, before we go into it, please remember to like and subscribe to my channel, share it with your friends so that we all can benefit as a community. All right, so we're at number 8. This section is algebra relations, functions, and graphs. Part A of section 8 says the function f and g are defined as follows. Now, how this is expressed, a lot of students generally misinterpret or misread it, but I want to tell you that the expression of the function f and g are the very same things that you're used to seeing in class, where a teacher would write, where the teacher would write, would write, for example, why is my screen doing this right now? All right, so the touch is giving me a little issue. All right. So the teacher would write, for example, f of x, and they'll put the x in bracket and equate it to x squared plus 3. This is the very same thing that this expression is saying. F is a function of x, which maps onto x squared plus 3. This is saying that for each input value of x, it will map onto an output value y by the function x squared plus 3. They have also given us a limitation on x to say that x must be greater than or equal to 0 for the f function. So for the f function, there is no value allowed for x that's less than 0. That means x cannot be negative, right? In the f function. And then in the g function that you generally see is g of x in bracket there, is equal to 2x plus 2, where x is an element of real numbers. That means that x is any real number, whether or not it is a positive number, negative number, whole number, decimal, fraction. X can be any one of those in the g function, right? And I'm hoping that you would have known that f is quadratic while g is linear. What makes f quadratic is the square on the x. What makes g linear is that the input is raised to a power of 1. Now, what did they ask us to do? They said calculate the value of g of -1. Now, what does that mean? Now that I've written this in this form, it makes it easier for you to see what g of -1 means. Because inside the bracket here is a -1, and that replaces x. So when you see a function and a number in the bracket there, it's an indication of what your x value is. Now, if it asks you to calculate the value of g of -1, you're substituting x as -1 into the g function, and the g function here, the g function was 2 times x plus 2. So I'm writing 2 times -1. Since x is -1, that gives me -2 plus 2. -2 plus 2 is 0. So the value of g of -1 is 0. What does that mean? It means that when x is a -1, the corresponding y value would have been 0. Awesome. Let's continue. It says write an expression for g inverse of x. Write an expression for f inverse of x. So for my f function, let's come over here. The f function, focus, f. So the f function, which y would have been equal to x squared plus 3. Notice the multiple variations of how we can express a function. So they have given us this expression. I would have written this expression, and this expression now is the very same thing. So all three are saying the same things. So when you see them, you must be able to interpret they're all saying the same things. Now, in finding the inverse, I wrote it in terms of x and y because I'm going to replace the input with the output, and then I'm going to rearrange all of the function. So the first step is that x becomes my subject now, and y is squared plus 3. Now, this is not the full inverted function because it wasn't just x and y that was a part of the function, but the square and the 3 were also a part of the function. So when we invert everything such that y becomes the subject of the statement. So we moved y from its original position on the left-hand side. We carried it to the right-hand side, but now it's no longer the subject. For every function, y should be the subject of that function. Because y is your output value, it depends on x, right? So we're going to be subtracting 3 from this side, and we have to do it to the other side. We call this the balancing method. So we are getting rid of 3 from here. Now we have x minus 3 is equal to y squared. Now y squared, y should be the subject, therefore the square should not be on y. So I'm going to eliminate that by doing the opposite of square, which is square root. And I must do it to both sides of the equation. So I square root both sides. What is now this statement? The square root of x minus 3 is now equal to y. Since y is the subject of this new statement, this becomes my inverse function. So f inverse of x is the square root of x minus 3. Awesome. Let's continue. All right. They say derive a simplified expression. So we are to derive a simplified expression for g of f of x. Notice how I read that. G of f of x. What does that mean? When we read, we start from our left. So we started with the g function. So it means that it is the g function that is my main function, right? I'm going to write that down. What the g function is 2 times x plus 2. Why didn't I put any x there? Because inside the g function, they said I should put f. So where do I put it? It is always the case that you replace x. Whether or not it's with a number or an expression or a variable, you're always replacing x, nothing else. So we replace x with what? The f function. What did the f function say? Here's the f function, x squared plus 3. Now, I have done correct substitution, but now the statement said, write the expression, a simplified expression. So now I'm supposed to expand that bracket. Remember that when we expand the bracket, all terms inside the bracket will be multiplied by the term outside. So we're saying 2, and this, when I said outside, let me just explicitly ensure that that is clear. The number that is multiplying the bracket is directly attached to the bracket. There is no sign attaching it. So the 2 that is over here, this plus 2, that plus 2 is not being multiplying. It's not multiplying the bracket. It's the front 2 here that's multiplying that bracket. So I will say I will say 2 times x squared, and that will give me 2x squared, and 2 times 3, that will give me 6, and I'll add my additional 2 that is outside of the bracket. Now that simplifies to become 2x squared plus 8. I can only add like terms, so the 2x squared is an independent term because it's not alike as the 6 and the 2, which are constants, so I can add those. Now the simplified expression is 2x squared plus 8. All right, we continue. All right, let's see what this one has to offer. The statement says, given that f of g of x, I always ensure that I do some underlining to highlight what exactly am I given. It says, given that f of g of x is this expression, solve the following equation. Solve it. In order to solve an equation, we're finding the value of an unknown quantity. If it's one equation, there should be one unknown variable. So you want to have clean statements, right? So how is this different from what's here? One statement says f of g of x is equal to 2x squared plus 8x plus 7. The said function f of g of x has another expression of 2 times g of f of x plus 15. What do? I know from the beginning that f of g of x is 4x squared plus 8x plus 7. So that is the expression of f of g of x. But they're also saying it's equal to 2 times the g of f of x function plus 15. So I'm equating that. What am I putting inside this bracket? We just worked out what g of f of x was. So that's 2x squared plus 8. So now I have two sides of my equation. X is the only variable in it, so I'm about to solve. All right, let's solve. Now, the left-hand side cannot be simplified, but the right-hand side can be simplified because the right-hand side have brackets there to be expanded. So we're going to write back the left-hand side as 4x squared plus 8x plus 7 is equal to 4x squared. Where did I get that from? 2 times 2x squared will give me 4x squared. Plus 2 times 8 will give me 16. Plus the 15 that's on the outside. Now this side can be simplified a little bit further because those are constants. They can be added. So we will add those to become 31. Now what's my next step? I want to solve, So since I want to solve, it means that I need to put my like terms together in an effort to get x to become the subject of the statement. So I will now group these. I'll get the 4x squared over its counterpart here, which is 4x squared. Notice that I subtracted it from the right, so I must subtract it from the left. What happens here is that they cancel each other out. What am I left with here? I'm left with 8x plus 7 is equal to 31. What was the aim? The aim was to solve. I want to find the value of x. So I'm going to be using my balancing method, continuing that. I'm going to remove the 7 from here, and I'm going to remove it from both sides, so that cancels that. I am left with 8x is now equal to 24. What do? I need to get rid of the 8. It was multiplying x, so I will divide both sides by 8. Now what's the solution? X is equal to 3. I would have solved, because when you're asked to solve, it means you're finding the value of the unknown variable. All right, let's continue. Geometry and trigonometry. So we are at the geometry section first. The diagram below shows a quadrilateral O, M, and N. Quadrilateral M and N are the images of quadrilateral O. I'm going to highlight this here because when it comes on to transformation, the very first thing you want to know is which of those shapes is your image. Because when we transform, we want to know, where did we go? Where did I start? Where did I go? Now, so here it is indicating that O is the object. So here's my starting point. Let me just call that 1 for now. After it undergone 2 different transformations. So let's check this out. There are 2 transformations. One is transformed to M. The other one it has been transformed to N. Let's see what they've asked us. It said, describe fully the single transformation that maps quadrilateral O onto quadrilateral M. We are heading for 3 marks, so let's see if we can get all 3. All right, so we're describing fully the single transformation that maps O onto M. So here, my original shape is O. I went to M. One of the clearest and easiest transformations to identify is an enlargement, because it's the only transformation that changes the size. It changes the size of the object. So once there's a change of size, we can say, boom, it is enlargement. I'm working for 3 marks, so I've given them the name, enlargement. That's 1 mark. What else am I working for? If it's an enlargement, I must state the scale factor. So I got 1 mark for stating the name. I now need to tell them the scale factor. What's the scale factor? The scale factor indicates by how much times bigger is the image in comparison to the object. And when we talk about what am I comparing, I'm comparing the length of the sides. So that again, I am comparing the length of the sides. So we're not comparing the size of the shape in terms of its area, but the length of the sides. So if I should look at any 2 sides that correspond to each other, for example, if I take this side and I take this side, and I'm just going to be using counting boxes here. So this one went 1, 1, this one went 2, 2. So I would look at dividing 2 by 1. Why am I dividing? I want to see how much times bigger is the object in comparison to its image. So I'll divide the length of the image by the length of the object and see how much times bigger. We'll see that this is 2. So it therefore means that the length of each side of my image is twice the length of each side of my object. You could use a ruler to measure it if you want. If it makes your life easier, you can use your ruler to measure it. And let me just show you that. I could use my ruler. So taking my ruler, I'm comparing now, because these are slant lines, so they're here. You can see that this is approximately 1, 2 and a. Is that 1? Yeah, 1, 2 and a half. This one. Let me just put this back onto here, because the scale here might not be, the diagram here might not be drawn to scale, because that's one of the things too that we look at when we measure. You might have an issue that the diagrams are not drawn to scale. So it is safer. It is safer to use the coordinates here to say that this would have gone across 1 box, this would have gone across 2 boxes, and it gives me safety here in terms of not just measuring the length of the line, especially when they're not drawn to scale. And then I can compare, and I said we can compare any 2 sides. So if I was going to use these 2, we have to ensure that the 2 sides that we compare are corresponding. So I would use this one up here, 1, 2, 3, 4 boxes, and I could say 4 divided by 2 is still 2. So I know for sure that my scale factor is 2. What's the one last thing that I must tell them when it comes on to an enlargement? You must include this in an enlargement. So we have told them the name, we have told them the scale factor. Now I need to tell them the center of enlargement. Once you have identified that it is an enlargement, you need 3 things to fully describe it. Once you have identified that it is indeed an enlargement, you will need 3 things to fully describe it. What am I doing now? I'm trying to find the center of enlargement. How? I'm aligning the vertices of 2 corresponding points. I'm aligning those. When I align them, I draw a line and extend it as far as possible. And I will connect 2 other corresponding points. And when I say corresponding, when you look at the object and the image, they should be representing the same position on the 2 shapes. So I will also align those. What am I searching for? I'm searching for their point of intersection. Where does the 2 lines connect? They meet right here. that becomes my center of enlargement. X is written first, Y is written second. Your center is a point. You indicate your X and Y coordinates, always remembering that your X coordinate is written first. Now this fully describes my transformation, and I can write that in a paragraph where I would state that the transformation from O to M is an enlargement by scale factor 2 and a center of 1, negative 1. Fully described that. All right, let's continue. The next one here is just fully describing how did I get from O to N. How do I get from O to N? Since it's on the same Cartesian plane, I remove that so that there is no confusion here. O to N. We can clearly eliminate it's not an enlargement. What else do we eliminate? We also eliminate if it's a translation. Why do I eliminate those first? Because those are the easiest to spot. If it's an enlargement, it's either bigger or smaller. If it's a translation, it's just a shift. There should be no change in the orientation, meaning there should be no flip, no turn. So because I can clearly see that this one doesn't look exactly like that one in terms of the orientation, N doesn't look exactly as O in terms of its orientation, it means that it's not a translation. It is either a reflection or a rotation. So I'm going to eliminate reflection first. So see, is it a reflection? If we reflect, if it is a horizontal line, it would either be directly below or directly above. It's neither, so it's not a horizontal reflection. If it's a vertical reflection, it's directly to the left or directly to the right. It's not a horizontal reflection. Is it a slant reflection? And based on where the image is, I'm going to draw the slant line in this direction because it must be flipped across the mirror. So if it should be flipped across the mirror, then the mirror line would be slanted like that. Am I seeing a slant reflection? Remember, when you reflect, your object and your image should be on opposite sides of your mirror via a perpendicular line. So if this is slanted, then the line that is perpendicular to that would be slanted in the other direction like this. And I draw my line. All right. Is it a reflection? Why? When I look at how this is oriented O versus how this is oriented N, I can see that the flip should be looking like something like that. But if you look at your lines, they're not correctly aligned. So it therefore means that if I flipped this across, it should flip and come somewhere right here. And I'm not seeing that. So that means it is not a reflection either. I have now boiled it down to it must be a rotation. Must be a rotation. So saying that it is a rotation, now I can go into what is the angle of rotation. Well, once I've identified that it is a rotation, now I can fully describe my rotation. I've identified one, I'm going to write it down. It is a rotation. So let me write that over here. I know it's a rotation. 1 mark, identifying the correct transformation. 1. 2, after you've identified it's a rotation, you need to give them the angle. And the angle includes direction. So I will indicate now, where did I go? I can go clockwise or I can go anti-clockwise. How do I determine the angle? We're checking between 3 angles. Is it a 90? Is it a 180? Or is it a 270? Those are the only 3 that we're testing for. Now, if I decide, and I can choose my direction, so you're not bounded by a particular direction, you can choose which direction you want to go. I generally prefer to go anti-clockwise because these are positive angles. So I'm going to go anti-clockwise. Moving from quadrant 1, quadrant 2, quadrant 3, quadrant 4, anti-clockwise. Moving from one quadrant to the next would have been 90. So this, if I went here, it would have been 90. Moving from here, come here, that is 180. Moving from here, over here, would have been, sorry, moving from here all the way here would have been 180. Moving from here all the way around here would have been 270 if I went anti-clockwise. So all I need to do is to look at what quadrant I started in and what quadrant am I now at. Based on that, I can determine what angle it is. If I move from only one quadrant, 90. Two quadrants, 180. Three quadrants, 270. Look at my direction. Based on where I am, I can see that I'm at a 180. So my angle is 180 degrees rotation. There's one angle that we don't need to give direction for, and that's the 180, because a half a turn in any direction is the same. A half a turn in any direction is the same. So the last thing I need to give them, because it's a rotation, is the center of rotation. Can't leave that out at all, otherwise I would not get my full marks. So I want all full marks, so I'm going to give them the center of rotation. All right, so let's put back the angle there. That's 180 degrees. So how do I find the center of rotation? Just like with enlargement, you need to find two corresponding points of your object and your image. You're going to align those and connect them. One. Aligning another two and connecting them. Two. Am I done for rotation? No. There's something special about rotation that we must do when we're trying to find the center of rotation. After we have aligned our corresponding points, we cannot generally assume that the center of rotation is where the two lines meet. This only occurs in some situations and not all. For this one, actually, it will, and you will see that, but I don't want you to take it for granted that it is always going to be the case. What you should do, once you have aligned your 2 points, is to now do what we call a perpendicular bisector of these two lines. Perpendicular means that where I cut this, so let's call this line 1 and this line 2. Line 1, the perpendicular bisector of that must be vertical, since line 1 is horizontal. So the perpendicular lines run in opposite directions and they meet each other at a right angle. So this, and because it's a bisector, it will divide the line into two equal parts. So like that. Notice that since this stretches across 6 units, then the perpendicular bisector must be in the center there. Since this line, line 2, is a vertical line with running at a gradient of +1, then the perpendicular bisector would be running at a gradient of -1 in the opposite direction like this. And it must run through the line in the center of the line since it's a bisector. So I note that the two perpendicular bisectors meet. So perpendicular bisector 1, perpendicular bisector 2, they meet each other here. So that means my center of rotation is a point, and it's 0, 0. Always indicate both X and Y. Awesome. Let's go. We're almost there. Next. So we've earned 6 points. On the diagram, we should draw the image of quadrilateral O after it undergoes the following transformation. We're going to do a translation by vector -5, 2. Label this L. Let's go. So we're translating O. Have a lot of things happening on here, so I'm going to remove some of them for clarity. All right. Removing some of those for clarity. So we want to translate O, -5, 2. Let's write that down, -5, 2. What does this mean? Your first number is indicating your horizontal, left or right. Your second number is indicating your vertical movement, up or down. So moving O I should move it -5, so I move a point. I'm moving points. I have 4 vertices to move. See them? Right there. I'm moving each one of them. I'm going to move each one -5, 2. -5 is an indication that I'm going 5 units to the left, because the negative is an indication of a direction. So I'm going 1, 2, 3, 4, 5, and I'm going to go up 1, 2. Notice I traveled on the straight lines. So that's my first point there. Moving this one 1, 2, 3, 4, 5, 1, 2, putting that point there. 1, 2, 3, 4, 5, 1, 2. Why did I go up? I went up because the 2 is positive, and that's my vertical movement. It's indicating to go up. 1, 2, 3, 4, 5, 1, 2. I've placed all of these points now, so I can take my ruler. We draw straight lines. We want our diagrams to be clean. All right. I connected all the points and I would have formed my new shape, and they say I should label that L. So I do all that is required to maximize my marks. All right. We continue. Next, they've asked us, reflect a reflection in the line y equals -1, label the image P. All right. What are we reflecting? We're reflecting O. So all of the changes that are occurring to the image O, to the object. So this is my pre-image right here, O, and that's what I'm changing, right? So let's go. They say I should do a reflection in the line y equals -1. Y equal -1. This line, what type of line? If the line indicates y equals -1, and you remember, in the equation of a line tells us 2 things. It generally tells us 1, if it is in slope-intercept form, it tells us 1, what's the gradient of the line, and 2, what is the y-intercept. Your gradient is generally the coefficient of x. Since there is no x term in this equation, it means the gradient is 0. What does that therefore mean? It means it's a horizontal line. Only horizontal lines have 0 gradient, so the line must be horizontal. That's 1. 2, the -1 is an indication of where does the line run through the y-axis, the y-intercept. So the y-intercept is -1. The line is horizontal. So we can just go ahead, take our ruler, align it to the -1, and we're going to draw a straight line running through that. This line is the line y equals -1. They ask us to do a reflection in this line. Since it's horizontal, take note of where your object is. From the mirror, it should go in the opposite direction. So we're going to flip this across the mirror. The same amount of distance it is above is the same distance it is below the mirror. So we take each point. Since this one is 1 unit up, we go 1 unit down. This one is 2 units up, we go 2 units down. 2 units up, 2 units down. 2, 3, 4 units up, 2, 3, 4 units down. I have all my vertices, so now I can go ahead and connect these dots. Connecting the dots. All right. Did they ask me to do a specific labeling in terms of a letter that I should use to label this one? They said use P. I want all my marks, so I come in and I'm going to indicate this as P. Awesome. Yes, we are there. What's next? Bearings. A buoy B and a lighthouse L are 95 kilometers apart. The bearing of B from L is 230 degrees. Using a scale of 1 centimeter to 10 kilometers and a space provided below, complete the diagram to show the buoy B relative to the lighthouse. Indicate the given bearing on your diagram. All right. So let's go back to the very first thing that they told us about the distance. B from L is 95 kilometers apart. They say the bearing of B from L is 230 degrees. So let's look at that. We already have L, and they told us it's from L, so our beginning point would have been L anyways. So they've given us a start. We are grateful for that. They've given us a start. Now we're gonna go to B. Before you decide where B is, just look at where L is and look at the bearing. If I went, so we put in some little guiding lines. So we know that this would be east, this would be south, this would have been west. We need to know some basic bearing angles as well. We need to know that this is 90. We need to know that this is 180. We need to know that this is 270. These are foundation. We know these. Now we're going to use this as our guide now, our guide. We want to go 230 degrees, 230. What does that mean for us? We want 230. We must pass 180 because 230 is bigger than 180. We cannot go all the way to 270 because that is greater than 230. It means that 230 would be in between here. So we have 180. We know that 180. How much more do I need on the 180 to get to 230? 180 plus what angle? 180 plus a 50-degree angle would have given me 280. So in between, additional to the 180, I will need 30 degrees more around to get my 280. So from here, let's say this is the line, I will need a 50-degree angle, 50-degree turn. And I will know that right here from L. So let's take that off now. All the way from the north line, coming around here, all the way around, that would have been 230 degrees. All the way. Notice I said all the way. Every bearing angle begins on the north line. So my measurement here has taken me from the north line. I can put my pencil anywhere on the north line and start my turn in a clockwise direction, taking it all the way around to get an angle of 230 degrees. Now that I know where the angle is, I need to know where to put the line, the point B. Based on the fact that they said from L to B, it's 95 kilometers apart. They've also said to us that 1 centimeter, so on my ruler, 1 centimeter on my ruler represents 10 kilometers. So I need to know how many centimeters on my ruler will indicate at 95 kilometers. So we say 1 to 10. So it therefore means that I need 9.5 centimeters. Because if 1 centimeter is 10 kilometers and I need 95, it means half of a centimeter would be 5 kilometers. So I now need 9.5 kilometers. So I'm going to put in, I know that from where I'm standing there, I need 9.5, so I would count that. 1, 2, 3. Let me go up a little bit on this to ensure that I can get the measurement. All right, putting it back in. You were measuring. All right, so 1, 2, 3, 4, 5, 6, 7, 8, 9 and a half. I'll take this now and draw a straight line. So B would be all the way down here. Put down my point, put point B, I'll need to ensure that my angle is correctly included here. And this now is the diagram that is worth 3 marks. This is good marks to get for, that is easy to get. Easy to get 3 marks. Let's continue. Vectors and matrices. This is the last question on the exam. The diagram below shows triangle OPR. The point M is the midpoint of OM. When you get this information, guys, when it comes on to vectors and matrices and you get a midpoint, it tells us something that we must remember. If I tell you that the middle of the line, it means it divides the line into 2 equal parts. If I am at the middle divides the line into 2 equal parts. That's the important, equal parts. So anything that's on one side is the same thing on the other side. That's important to note. And it says N does the same thing. N divides OR into 2 equal parts. It's giving us some more information. It says from O to M, the vector OM. So I'm going to put my arrow on the diagram based on what I'm told here. Vector OM goes from O to M. Vector ON goes from O to N. I indicate the directions because a vector has magnitude and direction. And the direction you go is very important. So we continue. What did they ask us to do? They say find in terms of U and V simplified expressions for the following. M to N. Start there. How do I get from M to N? So here is M, here is N. How do I get there? Using the vectors U and V. Now, we can't just go from M to N on this line because there's no description there in terms of U and V. But I can travel around. I'm going to take a connecting route. I can go from M to O and then from O to N. From M to O on the diagram, from M to O would have been described in terms of U, and from O to N is also described in terms of U. But pay attention. The vector OM was given as U. We're going in the opposite direction. We're going from M to O. So instead of using positive U, we'll be using negative U. We're then going to go from O to N. That is the actual direction of the vector itself. So that is remaining as positive V. We could also rewrite this and put the positive to the front and the negative to the back. So that's V minus U. They are representing the same quantities. So next, M to N. N to P. I want to go from N to P. How do I get there? Well, I have some options. So let's look at this. I have some options. Traveling on this diagram now, I have some options. I want to go from N to P. Here is my starting point. Start. Here is my ending point. How do I get there? Well, I could go this way. I could go that way. And then I could go that way. Why can I travel? Why can I travel on this vector even though it's not defined, this one? They told me that M was the midpoint, which means that if it is the midpoint, from O to M is equal to from M to P. That. So it means that this is also U. So when I said that something divides something in the middle, it must be equal on both sides. So from O to M is the same as from M to P. And it therefore means that we could also put in N to R. Since from O to N is V, then N to R is also V. Putting back my directions on my arrows. All right. So from N to P now, I'm going from N to O, that's negative V, because I went in the opposite direction of my vector, plus I am going U and another U, U plus U. So simplifying that, what does that become? That's 2U. Sorry, that's 2U minus V. Awesome. It says show that MN is parallel to PR. We're going to show that MN is parallel to PR, MN. So this is MN. We already know what MN is, we already know that MN was V minus U. What don't we know? We don't know what PR is. So this is MN. MN was V minus U. What is PR? Let's see if we can find PR. Because we can't compare them if we don't know what they are. So let's find PR. Want to go from P to R. How do I get there? Well, I just found PN, this one. So PN was 2U minus V. That was that. We know what NR is. It is V. So to get from P to R, let's take some of the stuff off the diagram. That's maybe confusing. Let's take off some of the stuff. All right. We want to go from P to R. So we're going to go here. From P to N, and then N to V. Let's try that. From P to N, then N to V. So how that, what would that provide? From P to N would have been the negation of the current vector because we're going in the opposite direction of that arrow. So it would be negative 2U plus V, changing those directions. And then we're going from N to R, that's same direction as the arrow, so that's plus V. What does that become? That is negative 2U plus 2V. Let's compare the two vectors now. Can I compare them to decide if they're actually parallel? Remember that we had written the positive ones to the front, the negative to the back, so I'm changing that around too. So that's negative 2V minus 2U. How do they compare? If M to N is V minus U and P to R is 2V minus U, parallel vectors should be multiples of each other. This is clear because this vector is actually 2 times V minus U. So what did I do? I factored out the 2, so that's 2 outside the bracket V minus U. So in comparison, since PR is actually 2 times the size of MN, and I could write that down, PR is equal to 2MN. This is what makes them parallel. So I could say since PR is equal to 2MN, they are parallel. They are parallel. Awesome. We are getting there. I hope that you're tuned in and staying along with me because we can, we must, we will be passing the exam. All right? Now we're at matrices. The matrix P written in terms of A, where A is a real constant, is as follows. P is the matrix 3A, 4, 6, and 2A. The question asks us to calculate the determinant of P in terms of A. Determinant, so I'm going to go ahead and highlight my diagonals. Determinant goes with diagonals. Going ahead and highlighting my diagonals. So this is diagonal 1 and this is diagonal 2. Specific formula is the product of diagonal 1. So the product of diagonal 1, that's 3A times 2A minus the product of diagonal 2, that's 4 times 6. 3A times 2A will give us 6A squared minus 24. So in terms of A, the determinant of P is 6A squared minus 24. The next thing says to determine the value of A for which matrix P is singular. We want the value of A that makes matrix P singular. What does that mean? Interpretation. When a matrix is singular, its determinant is equal to 0. So what this is saying is that when 6A squared is 6A squared, what value of A makes 6A squared minus 24 equal to 0? Singular matrix. A singular matrix has a determinant that is equal to 0. So from part 1, we already know what the determinant is. part 2 says to equate this determinant to 0 and solve for a. So we're going to solve for a. Since I have 6a squared minus 24 being equal to 0, therefore means 6a squared, add 24 to both sides, will be equal to 24. Divide through by 6 on both sides. A is equal to 4. A squared is equal to 4. Finding the square root of both sides. A is equal to the positive or negative root of 4. So that means A is positive 2 or negative 2. Why is that important? Because if a number is squared to give you positive 4, that number could either be a positive 2 or a negative 2. And those are the two possible solutions of A. All right? Last part of matrices. Determine P inverse for which P is non-singular. This was important to note that you cannot find the inverse of a singular matrix. So if P was singular, you could not find its inverse. So they're not saying in the case that P is singular, they're saying what if it's non-singular? What would have been the inverse? Now, the inverse is 1 over the determinant times the adjoint. So this now we need to know, as this is not on the CXC formula sheet, you need to know that the inverse of a matrix has this particular formula. We already worked out most of it already. Now we know what the inverse is. The adjoint is now the last part. The adjoint is to rearrange your numbers on your diagonals. So all I'm doing now is to switch around the diagonal one. So this becomes 2a, this becomes 3a. Notice I said switch around the elements. We're switching around the elements on diagonal 1. I did that. What do I do to the elements on diagonal 2? There's no switch, but there's a change of sign. On diagonal 2, we're going to change the sign of your numbers. So if it was positive, it becomes negative. If it was negative, it would have become positive. So your adjoint is the matrix itself in rearranged form. Diagonal 1, your elements are switched. Diagonal 2, your elements are, you change the signs of your elements. So please do note that on diagonal 2, you do not switch around your elements, you only change their signs. To complete this now, we're going to use our multiplication of a fraction by all the elements inside. So this becomes 2a for first element over 6a squared minus 24. So we're completing that. Negative 4 over 6a squared minus 24. Then negative 6 over 6a squared minus 24. And then we have 3a over 6a squared minus 24. Now, it is common for us to reduce the elements. If we have fractions, we write them in their simplest form. So I'm going to write the simplified version of this matrix right here. We can reduce by the first one by 2. So this becomes a over 3a squared minus 12. Notice I could have factored. So let me just pause here. I could have factored the expression of 6a squared minus 24 by right here. I could have factored this by a 2 in order to be able to cancel the 2 from the top. So if I'd factored out 2 here, if I'd factored out 2, I would have gotten a 12 inside, right? So the next part, if I also here I factored out 2, so this at the top now, we can have 2 there. It's a negative 2. Factoring out 2 that to cancel that would give me 3a squared minus 12 again. We could have factored out 6 from the denominator of the third one here, because both 6 and 24 is divisible by 6. So if I'd factored out a 6, that would be negative 1. This is a squared minus 4. The bottom one, we could factor out a 3, since the 3 is the numerator for this one. So we would get a divided by, if we factored out a 3, that would be 2a squared minus 8. And why did I do that? Because when you write your fractions, you want to have your fractions in their simplest form. So if a fraction can be reduced, you're encouraged to reduce those fractions. All right, we are finally almost at the end. Write down the 2 by 2 matrix that represents a Write down the 2 by 2 matrix that represents a counterclockwise rotation of 90 degrees. So we want a counterclockwise rotation of 90 degrees. I'm going to do something here. I'm going to write up my little Cartesian plane. This is x. Sorry about that background noise. So this is x, this is y. What am I doing? I'm trying to figure out what is the matrix for my 90 degree rotation anti-clockwise. And this unit matrix that we're looking for is a unit matrix of allows only elements of zeros and ones, whether positive or negative. So what I'm doing now is that I'm going to put on 2 points on my Cartesian plane. One where A is 1, 0, and the other where B is 0, 1. What I'm doing is to put 2 points 1 unit away from the origin, and they would represent now my unit matrix of 1, 0, 0, 1. We should know this matrix. Now, because we're going to be rotating around the origin, 1 unit away from the origin, this becomes my unit matrix. Now, this now does not represent my 90 degree anti-clockwise. I want to find my 90 degree anti-clockwise. Now, counterclockwise, if I should go counterclockwise, look at what's happening. If I rotate A counterclockwise 90, where would it fall? 90 degrees. So A would now be where B is if I rotated it anti-clockwise, counterclockwise 90. Where is B? That's at 0, 1. So this would have been A, this would have been B. So this is A prime, and now I'm going to find B prime. And this is a 90 degree anti-clockwise that we're doing now. So I look at where B is now, and I'm going to rotate it 90. 90 degrees rotation anti-clockwise would take me there. What's that point? That point is -1, 0. So what does that mean? It means that this matrix would have been the matrix that transforms any point using a 90 degree anti-clockwise rotation. That is what they just asked me for. So I can find any matrix for a rotation 90, 270, 180, whichever it is. I just need to put down my unit matrix of A and B and move them along the Cartesian plane to see where would they go if I did that particular rotation. All right, so this is the solution for the 2 by 2 matrix that would represent an anti-clockwise rotation of 90 about the origin. This is matrix X. So matrix X. So notice they said label it X. Next thing they've asked us to do, counterclockwise rotation of 90 about the origin, followed by a reflection in the x-axis given as Q. So they're not asking us to identify if Q is this. They're telling us that that's Q, and we should do a double transformation. Why do I say double? They said followed by. So I'm going to do one, then do the other one, representing a reflection in the y-axis, and we should label this T. So we want matrix T. What's matrix T equal to? When we transform a point, so we're transforming a point, xy, by a matrix, we multiply the point by the matrix. So if I had point, let's say this is point P, and I should transform P, it says counterclockwise rotation of 90 about the origin. So the first thing I should do is the counterclockwise rotation. Your matrix is always written to the left of the point, So here's point P, matrix. The first matrix being applied should be at the left of the point. So my 90 degree, which is my 0, 1, negative 1, 0, which I found. This is my 90 degree rotation. It said followed by mean that the next one is to the left of that as well. So the left of that would have been my reflection of negative 1, 0, 0, 1. So this is my reflection. What do? These two matrices are multiplying each other. And when they multiply each other, I can then use the result of them to multiply P. P is something I created to multiply P. So what I'm going to do now is to multiply my two matrices, remembering that when it says followed by, the very first one is written to the point. The point is on your right, the matrices are on your left. Followed by, the last one that is followed by is the last one written to your left. And I'm going to do my multiplication of my two matrices, because as long as I'm doing matrices transformation, I'm multiplying the matrices. I identify the rows from the one on the left, the columns from the ones on my right, and I'm going to multiply rows by column. So since these are two 2 by 2s, my answer should be a 2 by 2. Row 1 with column 1, so this is row 1, column 1, row 2, this is column 2. So row 1, column 1 first, row 1, column 1 first. Negative 1 times 0 plus 0 times 1, that's still 0. Because negative 1 times 0 is 0. 0 times 1 is 0, so that's 0. I'm going to go to row 1, column 2 here. Negative 1 times negative 1 is a positive 1. 0 times 0 is 0, so that's positive 1. Row 2 now with column 1. 0 times 0 is 0. 1 times 1 is 1, so that's a 1 there. Row 2, column 2. 0 times negative 1, that's 0. 1 times 0 is 0. So the matrix T that we're looking for is 0, 1, 1, 0. This matrix represents a double transformation of a rotation of 90 followed by a reflection in the y-axis. So if I had any point that I wanted to apply this to, I would use it to multiply that point, making sure that the point is on my right and the matrix is on my left. Are we through? Yes, we are. We are at the end of our test. I hope that this video would have helped you a whole lot. If there's anything that I need to address, don't forget to put it in the comment section and come back for many more videos. Recommend it to your friends. Allow them also to get some knowledge and pass the exams. Don't forget to like and subscribe and share. See you all in a few.